Hey everyone! For our colloquium project this semester, we researched the impacts of climate change on the dengue fever. So, firstly, here's a little bit about what the dengue fever even is. It is a mosquito borne viral infection caused by the dengue virus. There are four distinct serotypes, which is important because being infected with one type doesn't make you immune to the others. It is transmitted to humans through the bite of infected female mosquitoes. It is not contagious from person to person, rather, the virus must go from a human to a mosquito and back to another human. This fever is most common in tropical and subtropical climates worldwide. It thrives in urban and semi-urban areas where there is standing water that mosquitoes can breed in. Once bitten, it typically takes 4 to 10 days for the virus to begin affecting the body. Some climate drivers include rising temperatures, where warmer weather speeds up mosquito development and shortens the time it takes for the virus to become infectious. Additionally, there's extreme rainfall, where floods and heavy rains create stagnant water pools, leaving it as a breeding ground for larvae. And there's humidity, because high humidity increases mosquito survival and leads to higher biting rates.
So to expand more on what Harshvi just spoke about, let's talk about the spread of dengue fever. So, as she said, mosquitoes bite people and become infected, making the mosquitoes something called vectors, which are basically a species that causes infection without actually showing any symptoms themselves. So the two species of mosquito that are capable of being vectors are Aedes aegypti and Aedes albopictus. Now, the mosquito takes about 8 to 12 days before it's actually capable of transmitting the virus, because that gives the virus enough time to breed within the salivary glands of the mosquito. And the mosquitoes prefer a humid and subtropical climate because it's optimal for the standing water that mosquitoes use to lay eggs.
Okay, and now we can move on to section 3, which is effects of the dengue fever. In terms of symptoms of the dengue fever, there was, of course, high fever, a severe headache, pain behind the eyes, joint and muscle pain, nausea and vomiting, skin rash, as well as fatigue and weakness. These are all things that come along with any common cold or flu that you might see, but the symptoms there were definitely a lot more intense and severe than what your common cold might give you. There were also some social and economic effects. Socially, of course, it increased the strain on families and caregivers. So when people can't go into work, they can't make as much money, they can't provide for their families, and that puts a lot of strain on their families. This can lead to missed school days for children and students, specifically because either their parents can't take them to school, or maybe they were sick themselves and they were unable to go into school, as well as reduced productivity in daily activities where you won't have as much energy or as much time to do things if you're sick, as well as, of course, overcrowding in hospitals and clinics, which can happen when there's a large outbreak or an illness. Economically, of course, when people can't work, they can't make money, and that's the biggest thing. If people aren't making money, they can't provide for their families, as well as the high medical and hospitalization costs that come along with the illness. That can put a strain on families and kind of make it harder to provide, as well as governments are going to be putting more money into public health and making sure that they're trying to research and find a cure for this illness, as well as just general workforce productivity decline because fewer people are going into work.
So now you might be wondering, how does climate change really impact the dengue fever? Well, firstly, rising global temperatures are causing a geographic creep, shifting the ideal Goldilocks zone of 27.8 degrees Celsius or 82 degrees Fahrenheit northward and allowing mosquitoes to colonize new regions like southern Europe, California, and Florida. Secondly, higher temperatures significantly shorten the incubation period of the virus inside the mosquito, which means that they can pass the infection to humans much sooner after biting someone who is already ill. Thirdly, in areas that used to only see the dengue fever seasonally, warm winters now allow mosquito populations to survive year round, effectively turning what were once sporadic outbreaks into permanent health threats in those regions. Additionally, Global travel acts as a massive hitchhike system where infected travelers introduce the virus into new, climate ready habitats like London or Paris, frequently triggering local outbreaks in places that had never had them before and are not prepared for them. In regions where the dengue fever is already established, such as Southeast Asia and South America, shifting rainfall patterns have caused a dramatic 64% increase in cases compared to previous 5-year averages. Lastly, concrete heavy cities create heat islands that trap warmth and stagnant water, forming protected microclimates that keep mosquito larvae alive even when the surrounding rural areas are too cold for them to survive. So, we can see that these factors are all caused by climate change and then impact the transmission of the dengue fever. This image shows how the areas where mosquitoes can live and spread the dengue fever are expected to change over the next several decades. On the left side, the map shows environmental suitability, where the darker red colors represent places that are perfectly suited for the virus to thrive. As you move from the top of the map, around 2020, to the bottom of the map, around 2080, you can see that the red areas are spreading further north and south into parts of the United States, Europe, and China. The right side of this image specifically highlights this expansion in red. This shift is a direct result of climate change. As the planet warms, regions that were once too cold for mosquitoes are becoming new habitats. This means that by 2050 and 2080, millions more people will be living in danger zones for the dengue fever, simply because the climate has become warm and wet enough for the virus to survive there year round.
Hello, I'm Cristopher Carranza, and this is Section 5 Potential Solutions. While dengue fever may seem like an insurmountable problem, there are solutions that can be put into place to mitigate or reduce the overall spread. The first of these solutions is combating climate change. By attacking climate change at the source by reducing emissions, we can limit the spread of the habitable zone for mosquitoes, reducing the overall global spread of dengue fever. The next solution is urban design. Urban design can reduce mosquito attacks by sealing homes through tools such as nets. It can reduce the breeding habitats of mosquitoes by eliminating open water basins that allow mosquitoes to breed. And it can finally reduce the active seasons that mosquitoes are active for by reducing the heat island effect and moving the temperatures outside of mosquito active ranges. Another solution offered is mosquito management. The use of pesticides can reduce the overall population of mosquitoes and reduce the spread of dengue. And the final solution is medical prevention. Vaccinations such as Dengvaxia can prevent further cases of dengue and reduce the overall spread of dengue within a population. Similar to COVID, and if people are vaccinated, then it can reduce the overall spread within that population. In that case, that'll be it. Thank you for watching. Reach out for any questions.